So is this is water. This is a water wave. This is a water wave. This is a mechanical wave. Mechanical wave. Why? Because it requires a medium. What is the medium? Medium is water. So this is a mechanical wave. It is called requiring a medium, and this is a water wave. Now this is changing direction. Changing direction. What? Why is it changing direction? Because the speed is changing. Speed is changing. Why is the speed changing? Because here the depth is changing. The depth is changing. There's a smaller depth here. There's a bigger depth here. So because of so the depth is changing, that's why the speed is. Now, this is the ray. This is the ray. This it hits here. It hits here. This is the normal. This is the angle of incidence. This is bending towards the normal. This is the angle of refraction. And then it comes here and then it goes out and it bends away from the normal. This is angle of emergence, we call it. Now, the speed here, the speed here is more. The speed V1, this is V2. V2 is less than V1. The speed here is less. This is less in the shallow part. In the deep part, it is faster. Then again, it comes out. It it comes out of the same speed. That's why these are parallel. These are parallel. The rays are parallel. The rays are parallel. I mean, this is the ray. This is parallel to this, and also the wavefronts are parallel. The wavefront because wavefronts are perpendicular to this. So the wavefront. So now I go to the same concept but in light. Now this is also a ray. Again, this is refracting. This is the speed of this is light coming. That was water. This is light wave coming. This is speed is fast. The speed is high. The speed is high. Again, the speed is less. Speed is less. In glass, the speed is less. And that's why it bends towards the normal. It bends towards the normal. So this is we call it the refractive index. This n to 1. So speed, the refractive index of 2 with respect to 1. The speed in light medium 1 over the speed in medium 2. V1 by V2. V1 is more. V1 is greater than V2. The same thing I was explaining there, that the refractive index is greater than 1. And the refractive index are given by, these are values. So air has got one nearly one. I mean, vacuum is one, but air is this, ice is this. So more the refractive index, more the bending, more the bending. Now, that means all this is all this, but in water we don't have a refractor, but in glass and we have a refractor. Now, what else do we see? There are three things I told you. One is the speed of the wave. That's what I'm talking about. Then in last class, I told you speed is equal to wavelength into lambda into frequency. Now we have to understand what is happening to each of the parameter as it goes. Now the speed depends on the medium. Each depends on medium. That means if the medium is different, the speed will be different. It depends on the elasticity properties, all those properties. So this is not dependent on the source. That means the frequency is generated by the vibration of the source. So the vibration, the source generates this. This is not dependent on the part, the medium. So what is happening is there is speed here. It is some speed decided by like in the light, the speed here is the speed in air, and that's fixed. That is decided by the properties of air. Once it enters glass, the speed changes. The speed has changed because it is dependent on the glass. So has the frequency or the wavelength changed? Yes. not the frequency. The frequency is dependent on the source. It never changes. The wavelength will reduce. If the speed reduces, the wavelength reduces. If the speed increases, the wavelength increases. Now that's what is visible here. This is the wavelength, the gap. The gap is reduced because the speed has reduced, and the gap has again become same. The wavelength has changed. So if the speed is changing, the wavelength will change. Frequency never changes. That is the frequency generated when it was born. The disturbance was born. That remains the same. So if this formula, speed is equal to wavelength into frequency, always remember, if the speed changes, the wavelength is changing. This is constant. Whether it's water waves or light waves, everything everywhere is the same thing.